Hi students, this is Mr. Bodenreith, and in this short video, I'm going to talk a little bit more about the uncertainty methods we've explored over the past year or so, and give you some thoughts and guidance about how to apply this in the future with any investigation. So let's just jump right into it. So there are four main methods we've explored so far this year in terms of uncertainty. And the first one is taking multiple trials of the same phenomena. Okay, and then so what happens is if you take multiple attempts of the same phenomena, then what you can do is you can basically figure out the range of those values that you got, take the maximum minus the min, divide it by 2, and that can become your raw uncertainty. IB says this is an acceptable way to do an estimate of your uncertainty, and scientifically this is fairly sound. Second way is if you're using some sort of instrument from a manufacturer, let's say like a temperature probe or a motion detector or anything, you can look at what the manufacturer says is the resolution or the uncertainty in the readings that that instrument can take over this range of values or settings that you're using it. That's another legitimate way to estimate the uncertainty in your measurements. The third way is if you're using an analog instrument, say something like a meter stick we have in class, then remember, those have divisions, and if you look at the smallest division on that meter stick or any instrument, analog instrument, then you can estimate about half of that smallest division. So you want to keep that in mind, and obviously with a meter stick in particular, you want to be careful because remember when you're measuring something, it has a starting point and an ending point. And so you have to take into account the uncertainty on both the starting point and the ending point if, for example, you're using a meter stick. And then finally, the last way we've talked about it, or one of the ways we've talked about it, is if I'm using a digital instrument and I don't have manufacturer specifications, then using what's called the least count digit on your instrument is something that is acceptable. So in this case, if you look here, the multimeter is reading, let's just say it's a voltage it's reading. It's reading to the 10th place, to the 100th place on the volts. So I would say whatever that reading is would be plus or minus 0.01 volts. So when you report uncertainties, when you present raw measurements in any report from here on forward, somewhere near that information, meaning like right next to it, at the bottom of a table, certainly on the same page, you have to do two things. You have to indicate the uncertainty in that raw measurement that you're presenting to the reader. And so a couple of examples of that is the force of the pull was 75.2 newtons plus or minus 0.2 newtons. Another example would be the radius was 11.2 centimeters plus or minus 0.1 centimeters. Notice you're presenting the reader with the reading and the uncertainty in the reading. The other thing you want to do is you need to provide the source of that uncertainty. So in the first example from up above, somewhere near that reporting, you would say uncertainty in force values due to dual range sensor manufacturer specification. And notice I've listed a website there of a manufacturer. Or for the radius measurement, you might say something like uncertainty in radius derived from the smallest division of analog instrument meter stick. Okay, so let me just show you in this last slide one more example. This is how commonly I see students do this, and this is a good example because most commonly you're not going to present data, raw data in the form of a prose paragraph, but it's going to be in a data table. So how can you do the two things I mentioned in the previous slide when you're using a data table? Well, here's one example. Notice what the student has done here is they have provided in the table headings the measurement, the units being used, and they've also provided a measure of the uncertainty in the column headings for both the temperature and for the current. But then they've gone even further, and I think this is something you seriously want to consider. Notice there's a little star there and a little triangle there. And under the star, if you look at the bottom there, it says the source of uncertainty in temperature comes from the manufacturer's specification for the probe that was used. And again, the website is listed. And next to the triangle here, uncertainty in current values comes from the least count on the digital instrument. But in calculations later in this report, the uncertainty is derived from the range of values for repeated measurements. Notice what they did in the triangle one is especially nice because they've indicated, okay, in this table, I'm showing you that the uncertainty is this based on the least count, but in the future, I'm going to go max minus min divided by 2 and use that uncertainty in any future calculations. So this is a good example, a strong example of a student reporting the raw measurements and reporting the amount of uncertainty that is in each measurement and also the source of that uncertainty. So that concludes this video, and I hope this helps. Thanks.